Hello, Algebra 2 folks, and welcome to Factoring Day 2. You need your reference foldable, a pencil or a pen, and a calculator, and your thinking caps. All right, so this is your reference foldable. We've already talked about what it means to be a factor. Remember, that's undoing multiplication. We've talked about greatest common factoring, where we take out what is the greatest common between all the terms. And then group factoring when you have 4 terms, and that's group factoring is greatest common factoring multiple times. And now we are going to go ahead and finish trinomial factoring, which is factoring using the AC method when you have 3 terms, and the difference of perfect squares when you have 2 terms. All right, so we will get started. So if you'd open up to the trinomial factoring, go ahead and we will talk about the AC method in 3 terms. So first we take A, which is the coefficient, and we multiply it by C, which is the constant. A is the coefficient, that's the number in front of the x squared, the leading coefficient, and then C is the number that doesn't have a variable, that's a constant. Okay? Then we ask, well, what multiplies to make that number and add up to be the middle term? And if that doesn't make sense to you right now, it will, because I will do some examples. And then we turn it into a 4-term grouping problem. Well, we already know how to do 4-term grouping problem. So it's just the first 2 steps that we have to do differently when we do the AC method. All right, so these are the 3 examples I'm going to do with you. And I'm going to do each one of these steps. So first I'm going to take the A, leading coefficient. That is the number in front of the x squared. So there wasn't a number there, so that A is 1. And then C is the constant. Constant doesn't have a variable, so the C is 6. Take 1 times 6 because it says multiply them together. So A times C is 6. All right, so we did the first step, okay? Second step says ask yourself what multiplies to make the number 6 and add up to be the middle term. So this is where we are going to find factors of 6 that multiply to make 6 but add to make 7. Okay, so I would just write down all the factors of 6. 1 and 6, 2 and 3, and that would be a positive 1 times a positive 6 would give me a positive 6 if multiplying, and 2 times 3 would be a positive 6 if multiplying, but a negative 1 times a negative 6 would also be a positive 6 when multiplying, and a negative 2 times a negative 3 would also be a positive 6 when multiplying. So these are the 4 options for all multiplying to make 6. Now, which one, when added together, makes a positive 7? Well, negative 2 plus negative 3 would be negative 5, so that one isn't going to work. Negative 6 plus negative 1 would be a negative 7. That's not going to work. A positive 2 and a positive 3 would be a positive 5. That is not a positive 7. But if I add these 2 up, 1 plus 6, I get a positive 7. All right, so what I do is I come over here and I turn it into a 4-term grouping problem. The first term stays. The second term is replaced by your factors. So plus 1x plus 6x, and then the last term stays as well. So the only thing that changes is the middle 2 terms. And since I want 7x, I'm going to put an x on each of these factors. Okay, so now I have 4 terms. Well, what do I do when I have 4 terms? I group the first 2 terms, I group the second 2 terms, and I do greatest common factoring. What does 1x squared plus x have in common? Well, they have an x in common. If I divide out an x, I'll have an x. If I divide out an x out of a 1x, I'll have a 1. What does 6x and 6 have in common? They have a 6 in common. When I divide out a 6, I have an x plus 1. What do these two terms now have in common? Well, they both have an x plus 1 in common. So I'm going to divide out an x plus 1. And if I divide an x plus 1 out of this guy, they cancel, and I'm left with an x. And if I divide an x plus 1 out of these guys, I'm left with a 6. The two factors that multiply to make the original are x plus 1 and x plus 6. Excuse me. All right, let's do another one. You take A times C. A is equal to 1. C is equal to negative 16. And multiply them together and you get negative 16. Now we're looking for two factors of negative 16 that add up to be negative 6. Oh gosh, what are all the factors of negative 16? Well, 1 and negative 16, negative 1 and positive 16, negative 2 and positive 8, positive 2 and negative 8, 4 and negative 4, or negative 4 and 4, that's the same thing. And I think that's all. So all of those multiply to be negative 16. But which one adds up to be negative 6? Remember, what multiplies to make AC, but adds up to be the middle term. Well, 1 minus 16 would be negative 15. That won't work. Negative 1 plus 16 would be positive 15. That's not going to work. Negative 2 plus 8 would make positive 6. That's not going to work. 2 minus 8, yep, that's going to make negative 6. So we turn this into a 4-term grouping problem. Bring down the first term. That always stays the same. Replace the middle term with your new terms. So plus 2x minus 8x. That adds up to be negative 6x. And bring down the last term. Now we can go ahead and factor by grouping. So group the first two, find the greatest common factor. Yep, that would be an x. What's left over? X plus 2. Group the second half. What do they have in common? Negative 8. What's left over? X plus 2. We always want those to be the same, remember, in a grouping problem. Now we're going to factor out the x plus 2. When we factor out the x plus 2, we'll have x minus 8 left over. So the two factors that multiply to make this x squared minus 6x minus 16 would be x plus 2 and x minus 8. All right, that brings us to our third example. Okay, this only works when you have 3 terms. Okay, so here's my 3 terms, x squared, x, and no x. All right, take A times C. Oop, A this time is 3. So A, oops, sorry about that. A equals 3, and C equals negative 2. 3 times negative 2 is, you've got it, negative 6. So AC equals negative 6. For some reason, it's not letting me write over there. So A times C is negative 6. All right, so now we want two factors of negative 6 that add up to be 1. Ooh, well, negative 1 and positive 6. 1 and negative 6. Because remember, these two have to multiply to make negative 6. 2 and negative 3, and negative 2 and positive 3. Okay, so which one adds up to be 1? 6 minus 1 would be 5. Negative 6 plus 1 would be negative 5. Negative 3 plus 2 would be negative 1. So it must be 3 and negative 2. So I bring down my problem using those two factors. I'm going to have to erase here a little bit because for some reason I can't write way over on that side. Okay, so bring down the first term. The second term becomes negative 2x plus 3x, and the last term stays negative 2. Okay, and so now that I have my factors, I'm going to go ahead and erase those out of the way, and I'm going to turn this into a grouping problem. So I got my 4 terms, and 3x and negative 2x do become a 1x, so we group the first two together. What do they have in common? They have an x. That leaves us with 3x minus 2. And what do the last two group have in common? They have a 1. So then what do they have left? 3x minus 2. And then I factor out the 3x minus 2, and I'll have x plus 1 and 3x minus 2. And those two terms would multiply, those two binomials would multiply, those two factors would multiply to make the original equation. Okay, so just remember you got to take a times c. You've got to find two factors of 6 that multiply, or whatever that AC is, if it's 6 like it is here. You have to find those two factors that multiply to make 6, but also add to make that middle term. And then turn it into a 4-term problem, and you've got grouping going on. So that's why we learned how to group. All right, let's go ahead and learn the last method, which is the difference of perfect squares. So we got to know something about perfect squares. All right, so difference of perfect squares. You have to be able to identify each of the following. 1, do we have a difference? That means the problem better have a subtraction sign. Because if it doesn't have a subtraction sign, then it isn't going to be the difference of perfect squares. And the second thing is, do you have a perfect square? So what are the perfect squares? Well, let's talk about perfect squares. Perfect squares would be 1 times 1, which is 1. 2 times 2, 4. 3 times 3, 9. 4 times 4, 16. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. 8 times 8, 64. 81, 100. 121 is 11 times 11. 12 times 12 is 144. And so on. So you need to know your perfect squares. If you don't know them, just go ahead and write down 1 times 1 equals 1. 2 times 2 equals 4. 3 times 3 equals 9. Off to the side of your paper. And you will always get your list. Okay? So, make a list. If you can't memorize them, always make a list. Okay? Just like this. And so on. Okay? All right. Now, when you have a difference and you have a perfect square, then you're going to factor it using two factors. One's going to be negative, one is going to be positive, but they're going to be exactly the same except for one will be positive and one will be negative. So it's pretty easy as long as you can identify these, that we have these two things. All right, so example number 1. First of all, x squared. That's a 1x squared. Is 1 on the list? Yes, it is, right there. 49, is it on the list? Yes, it is. Is there a difference? Yes, it is. So the factors are x minus 7 and x plus 7, because x times x is x squared, and 7 times 7 is 49 with the negative. So one has to be a negative, one has to be a positive. Now here's what happens. The reason why this works is because see how this doesn't have a middle term? It has an A and a C, but no B. That's because we want the B term to cancel. All right, so this is what my teacher taught me. check your smiley face. Your smiley face says, I did kind of a bad smiley face there, really. Let me redo this here. There's the nose, and there's the mouth. So when you multiply the nose, you get negative 7x. When you multiply the mouth, you get positive 7x. When you add them up, you get 0 x's. That means no b, because the b is 0. All right? So these are pretty easy. If you can remember that you need 2 of the exact same, 1 positive, 1 negative. All right. Example number 2. 4. Is 4 on the list? Yes, it is. What makes 4? 2 times 2. Awesome. Is 9 on the list? Yes, it is. What makes 9? 3 times 3. All right. We have a negative sign, so we have a difference. So what did we say makes 4? 2 and 2. What do we say that makes 9? Well, that'd be 3 and 3. What are their signs? One's positive, one's negative. It doesn't matter which way you write them. They're exactly the same, but opposite in sign. Well, how do we know we did it right? Well, 2x times 2x is 4x squared. 3 times negative 3 is negative 9. Well, let's check our smiley face. 3 times 2x, well, that'd be 6x. And negative 3 times 2x, well, that'd be negative 6x. Well, and that cancels out to be no x. So we did it right. Yay! Happy smiley face. All right, next one, 81. On the list? Yes, it is, right here. What is that one? That one's 9 times 9, so 9 squared. All right, and then this is a negative 1. That's okay, 1's on the list. All right, so what makes 81? 9 and 9. And we want positive 81, right? But we want a negative w. So what makes w? Well, 1w and 1w. Okay, 1 is negative, 1 is positive. 9 times 9, 81. W times negative w squared. Check the smiley face. See if it works. Negative 9w, oops, negative 9w, positive 9w makes 0w. So we're happy. We made a smiley face. Okay, let's keep going. 16 on the list? Yes, it is. 25 on the list? Yes, it is. What makes 16? 4x and 4x. What makes 25? 5 and 5. Is it a difference? Sure is. One's positive, one's negative. Doesn't matter which way you go. All right, that'd be checking my smiley face. 4x, well, let's do 4x times 4x. That's 16x squared. 5 times 5, well, negative 5, negative 25. Then check your smiley face. 20x, negative 20x. Good to go. All right, here we go. 4, is it on the list? Sir, sure is. 7, is 7 on the list? Nope. Not a perfect square. So if it's not a perfect square, I know we have a difference, but we don't have a perfect square, then it is not factorable. Because we don't have 2 perfect squares. They have to be perfect squares. If they're not, it doesn't work. Oh, but sometimes trickery happens. And here's the trickery. 5 isn't on the list and neither is 20. But what does 5 and 20 have in common? You can take out a greatest common factor. 5 divided by 5. Well, that's x squared. 20 divided by 5, that's negative 4. And if you can do that, and then your answer, they're on the list, you can factor it again. Woohoo! All right, now why didn't that work on problem number 5? Let's go back. Well, because 4 and 7 don't have anything in common. Yeah, so it works down here, doesn't work here. So before you just identify that it's not a perfect square, you should actually find out if there's anything in common first, okay? A little bit of trickery. So now, is 1 on the list? Yes, it is. Is 4 on the list? Yes, it is. So the answer to this problem would be 5, because we bring the 5 out, keep that in front, and then we're going to have 2 answers again. What makes 1x squared? Well, an x and an x. What makes 4? 2 and 2. One is negative, one is positive. That is the final answer. So we have to have the greatest common factor there plus the difference of 2 squares there as well. Okay, let's take a look at number 7. What do they have in common? They have a 2 in common and they have an x. So the greatest common factor is 2x and 2x. So we take that 2x out. What's left over? X squared minus 36. Is 1 a perfect square? It sure is. Is 36 on the list? It sure is. So our answer is going to be, leave the 2x out there, and we'll go x minus 6, because what makes x squared? X and x. And what makes 36? Negative 6 and a positive 6. And that would be the final answer. All right, folks, that's all I got. Thanks for watching, and peace out.